Sir. Very good morning, students. Today we are going to see the software engineering subject, in which today's topic is cleanroom software engineering. So, where did it came from? The name cleanroom is derived from the process to fabricate semiconductor. The philosophy focuses on defect avoidance rather than the defect removal. Now, this approach combines many of the formal methods and software quality methods we have studied so far. Now, cleanroom is a shift in practice from individual to peer-reviewed engineering, from craftsmanship to increment development, from sequential to team correctness, from development to verification, from individual unit testing to statistical usage testing, and many more. What is actually the clean room designing engineering? So, clean room software engineering involves the integrated use of software engineering modeling, program verification, statistical software quality assurance. It also specifies design specification using mathematically based proof of correctness. It relies heavily on statistical use of testing to uncover high impact errors, and it also generally follows the incremental development process. You can see an incremental development process. So increment 1, increment 2, increment 3, increment 4, these are the increment development process here. Now your next topic is benefits of this cleanroom software engineering. Now, first is zero failure in the field. That is the total anyway. A realistic expectation is less than 5 failure per thousands line of control code on the first program execution in the first team project. So, short development cycle results from use increments, strategy, and avoidance of rework. New team should experience a twofold productivity increase on the first project and continue the increase and longer product life. So invest detailed specification and usage model help keep a product viable longer. Then why are clean room technique not widely used? Now, some people believe that clean room techniques are too theoretical, too mathematical, or too radical to use in real software world. Relies on correctness, verification, and statistical quality control rather than unit testing. And organizations operating at the ad hoc level of capability maturity model, same model that is. So there is no need to make a rigorous use of defined processes needed in all phases of the software life cycle. Now, clean room principle one, first is small term, independent specification, development, and certification subteams, and incremental development under statistical quality control, performance assessed during each increment using measure like errors per thousand line of code, rate of growth in MTTF, or number of sequential error free test cases. Feedback is used to process improvement, and the development plan is adjusted as needed. Clean room process team, first is specification team, second development team, third is certification team. In specification team, it develops and maintains the system specification. Now in development team, so it develops and verifies software, and also if the software is not compiled or executes during verification. And certification team, it develops set of statistical tests to exercise software after development. And reliability growth model used to assess reliability. Now, clean room principles second. Software development based upon mathematical principles. The box principle is used for specification and design. Forms verification is used to confirm correctness of implementation of specification. And program correctness is verified by team reviews using questionnaires. And second part, testing used on statistical principles. Operational usage profile needed. Test cases are randomly generated from the usage model and failure data is interpreted using statistical model. Now this is clean room process overview. Now clean room strategy, incremental planning, requirement gathering, box structure, specification. Now clean room strategy second, formal design and correctness verification. In formal design, specification or we can say block boxes, these are iteratively defined to become architectural design, that is the state box, and component level design, that is the clear box. And correctness verification, correctness questions are asked and unanswered from mathematical verification is used as required. Now this clean room strategy part 3, code generation, inspection, verification. Then box structures are translated into program language. Inspections are used to ensure conformance of code and boxes as well as syntactic correctness of code, followed by correctness verification of the code. And second is statistical test planning. A suite of test cases is created to match the probability distribution of the protected product usage pattern. Now this is the clean room strategy third. Now this is clean room strategy number 4, statistical use testing and certification. A statistical sample of all possible test cases is used rather than exhaustive testing and certification. Once verification, inspection and usage testing are completed, all defects are removed, then the increment is certified as ready for integration. Then in increment planning purpose, actually developing the right system the first time requires customer involvement and feedback throughout the development of the software cycle. Now facilitates the customer's clarification of the system requirements, requires management control of resources and technical control of complexity, and product quality requires process measurement and control throughout the software development life cycle. Now there are some increment benefits: concurrent engineering, stepwise integration, continuous quality improvement or control, continuous customer feedback, then risk management and change management. These are some of the benefits of the increment planning. Now is black box. Black box testing in which we don't bother about the intermediate state, what is actually executed and how it is. We just giving input and we expect output should be there. Now this specifies a set of transaction rules that describes the behavior of the system, component and responses to specific stimuli, makes use of inheritance in a manner similar to classes. So yes, producing R, similar history to response. State box, S into T is equal to R into T. Stimuli into state data is equal to response into state data. Clear box, S into T, R into 2. Stimuli into state data, response into state data. So state up, date and response production is allowed. Here it contains the procedural design of the state box in a manner similar to structural programming. And this box principle is used for transaction closure of stimuli and response, state migration within the box hierarchy, and for common services like reusable boxes from library. Now see, this is the formal specification and inspection. The state box model is treated in a similar in a system specification. The inspection process checks the program against the state based model, and the programming approach used is defined to make clear the correspondence between the model and the implemented system. And the last is the proofs used resemble mathematical arguments and are used to increase confidence in a inspection. Design verification advantage: first is reduce verification to a finite process, second improves quality, third lets cleanroom team verify every line of code, fourth result in near zero level of defect, and last one scales up to larger systems and higher layers, produces better code than unit testing. Certification step: here usage scenario must be cleared, usage profile is specified, test case is generated from the usage profile, reliability is computed in a recorded, and tests are executed and failure data are recorded and analyzed. This is specification, usage specification, high level characterization of the operational environment of the software, user person or device or piece of software, its uses workstation, session, transaction, then usage environment is platform or system load, usage access or classes are nothing but the cluster of similar user doing similar task. Now here in the next lecture we'll see usage modeling and many more things of the clean room software engineering. Thank you.